Galaxies in the scale of space *introduction *imagine, standing beneath a clear, starry night sky. Each twinkling dot above us may look small, but many of those lights are not just stars, they are entire galaxies, each containing billions, or even trillions, of stars, planets, and mysteries waiting to be discovered. Our universe is vast beyond imagination, and galaxies are the building blocks of this cosmic masterpiece. In this journey, we're going to travel far beyond Earth, far beyond our solar system, and even beyond our Milky Way galaxy. We'll explore what galaxies really are, the incredible variety of shapes and sizes they come in, and how they form and evolve across billions of years. We'll dive into the mind-bending scale of space, distances so enormous that even light, the fastest thing we know, takes millions of years to cross from one galaxy to another. From our home in the Milky Way, to our neighboring giant, the Andromeda Galaxy, and onward to the vast cosmic web of trillions of galaxies that make up our universe, we'll uncover how small we really are, and yet how deeply connected we are to the grand design of the cosmos. So sit back, and let's begin this incredible journey into galaxies and the unimaginable scale of space. What is a galaxy? To understand galaxies, we first need to think of them as cosmic cities of stars. Just as a city on Earth contains millions of people, roads, and buildings, a galaxy holds billions, sometimes trillions, of stars, along with planets, moons, clouds of gas and dust, black holes, and an invisible substance called dark matter. All of these components are bound together by one powerful force, gravity. But not all galaxies look the same. In fact, astronomers classify them into different types based on their shapes and structures. The most famous are spiral galaxies, swirling majestic pinwheels of stars and gas. Our own Milky Way is a spiral galaxy with arms that stretch outward like the spokes of a giant wheel. Then there are elliptical galaxies, which look more like smooth, glowing spheres or stretched out footballs, often containing older stars and less active star formation. And finally, there are irregular galaxies, which don't have a defined shape at all. These are often chaotic in appearance, shaped by collisions or interactions with neighboring galaxies. Galaxies also come in a huge range of sizes. Some are small dwarf galaxies with just a few billion stars, while others are giant ellipticals with more than 1 trillion stars. To put that in perspective, our entire Milky Way, with its hundreds of billions of stars, is only a medium-sized galaxy. What's even more fascinating is that galaxies are not just made of the stars we see. Most of a galaxy's mass is actually made up of dark matter, an invisible material that doesn't give off light, but still has gravity. Without dark matter, galaxies wouldn't be able to hold themselves together. So, at their core, galaxies are vast collections of stars, planets, gas, dust, dark matter, and black holes, bound together by gravity. They are the fundamental building blocks of the universe, and without them, the cosmos as we know it wouldn't exist. Our home galaxy, the Milky Way *. Now that we understand what a galaxy is, let's turn our eyes toward our own home in the cosmos, the Milky Way galaxy. This is the vast, star-filled island where Earth, the Sun, and our entire solar system reside. The Milky Way is a barred spiral galaxy, stretching about 100,000 light-years across. Imagine a single beam of light, the fastest traveler in the universe, taking 100,000 years, just to go from one side of our galaxy to the other. That's how enormous it is. Inside the Milky Way are somewhere between 100 billion and 400 billion stars, and around many of those stars are planets, moons, and perhaps even alien worlds that could harbor life. Our sun is just one of these countless stars, and our solar system sits about 27,000 light-years from the galactic center, tucked inside a region called the Orion Arm, a smaller branch. between two of the Milky Way's major spiral arms. At the heart of our galaxy lies something extraordinary. A supermassive black hole, called Sagittarius A. This black hole is about 4 million times more massive than our Sun, and although it doesn't glow with light, we can observe the swirling stars and gas around it. It acts like the beating heart of our galaxy, keeping the center in motion with its immense gravity. From Earth, we can see the Milky Way as a glowing band of light stretching across the night sky. Ancient civilizations often thought of it as a river of milk, a path of spirits, or even spilled grains of light. Today, we know it's the combined glow of billions of distant stars, packed so closely together that their light blends into a shining streak. And just like a city, the Milky Way has different neighborhoods. The central bulge is a dense, bright sphere of stars near Sagittarius A surrounding that are the majestic spiral arms, filled with young, hot, blue stars, and enormous clouds of gas where new stars are born. On the outskirts is the galactic halo, containing older stars and clusters, as well as a mysterious cloud of dark matter that holds the galaxy together. So, when you look up at the night sky and see that glowing band of stars, remember this: you are looking into your own home, a vast galactic city that has been around for more than 13 billion years. The Milky Way is not just our address in the universe, it is our cosmic heritage. Famous neighboring galaxies. Even though the Milky Way feels impossibly vast, it is far from alone. Our galaxy lives in a neighborhood of other galaxies, like houses clustered together in a cosmic town, and some of our neighbors are truly spectacular. The most famous of them all is the Andromeda Galaxy, also known as M31, located about 2.5 million light-years away. Andromeda is the closest spiral galaxy to us, and it's even larger than the Milky Way, containing over 1 trillion stars. If the night sky were dark enough and your eyes sharp enough, you could actually see Andromeda as a faint smudge of light without a telescope. What's even more incredible is that Andromeda is moving toward us, and in about 4 billion years, it will collide with the Milky Way. That sounds frightening, but don't worry. Galaxies are mostly empty space. When the two merge, stars will pass by one another, and the night sky will light up with one of the greatest cosmic shows in history. Another important neighbor is the Triangulum Galaxy, also called M33. It's a smaller spiral galaxy, about 3 million light-years away, but it still holds tens of billions of stars. Astronomers often study Triangulum to understand how galaxies form new stars, since it's rich in glowing nebulae and young star clusters. Even closer to us are the Large and Small Magellanic Clouds. These are two irregular dwarf galaxies that orbit around the Milky Way like companions. Visible from the southern hemisphere, they appear as cloudy patches in the night sky. The Large Magellanic Cloud is famous for hosting the Tarantula Nebula, one of the most active star-forming regions we know of. These galaxies are slowly being pulled apart by the Milky Way's gravity and may one day merge into it. Together, these neighbors remind us that the Milky Way is not an isolated island, but part of a dynamic community of galaxies, all bound together by gravity, and the interactions between them, from tidal pulls to future collisions, continue to shape the destiny of our galactic home. The local group, and beyond asterisk. If the Milky Way and its nearest neighbors are like houses on the same street, then the local group is the entire neighborhood. This collection of galaxies is bound together by gravity, and it's where our home galaxy belongs. The local group contains more than 50 galaxies, ranging from large spirals, like the Milky Way, Andromeda, and Triangulum, down to dozens of tiny dwarf galaxies. Most of these smaller galaxies orbit around the giants, much like moons orbit planets. For example, the Milky Way is surrounded by dwarf companions, such as the Sagittarius dwarf galaxy and the Magellanic Clouds. While Andromeda has its own retinue of satellite galaxies, the local group spans about 10 million light-years across. To imagine this, Think of the Milky Way as a single coin. The distance across the local group would then stretch to the size of an entire continent. That's the scale of our galactic neighborhood. But the local group itself is not alone. It is part of a much larger structure called the Virgo supercluster, which contains thousands of galaxies grouped together in clusters and filaments. Our local group is just one small piece of this enormous web. And beyond the Virgo supercluster lies something even grander, a supercluster of superclusters known as Laniakea. This gigantic structure stretches over 500 million light-years and contains about 100,000 galaxies. In Hawaiian, Laniakea means immeasurable heaven, a fitting name for something so unimaginably vast. So, from the local group to the Virgo supercluster to the cosmic web of Laniakea, we see that galaxies are not scattered randomly across space. Instead, they are arranged in patterns, like threads woven into a cosmic tapestry. And we, tiny humans, on a small planet in one corner of the Milky Way, are part of this breathtaking structure. Asterisk. The scale of space asterisk. When we think about the scale of the universe, our minds almost fail to keep up. The numbers are so large that they stretch far beyond human imagination. Let's begin close to home. Earth orbits the Sun at an average distance of about 93 million miles, what astronomers call one astronomical unit. That already feels huge, but on a galactic scale, it's nothing more than a step across your living room. The speed of light, the fastest thing in existence, travels at 186,000 miles per second. In just 1 second, light could circle Earth more than 7 times. Yet, even at that unimaginable speed, it takes 8 minutes for sunlight to reach Earth. To get from the Sun to the edge of our solar system, more than a day of non-stop travel at light speed. Now, let's push further. To cross the distance from Earth to the nearest star, beyond the Sun, Proxima Centauri light needs over 4 years. That distance is what we call a light year. The distance light travels in a single year. And remember, the Milky Way galaxy is about 100,000 light-years across. That means if you shined a flashlight on one side of the galaxy, someone on the far side would have to wait 100,000 years to see it. And beyond our galaxy, that's where the numbers become staggering. The Andromeda galaxy is 2.5 million light-years away. That means the light we see from Andromeda tonight actually left that galaxy long before humans even existed on Earth. In other words, when we look into deep space, we are always looking into the past. But even Andromeda is nearby compared to the true scale of the cosmos. The Virgo cluster of galaxies lies about 65 million light-years away, roughly the same amount of time since the dinosaurs roamed Earth. And the Laniakea supercluster stretches over 500 million light. These distances are so enormous that our brains can hardly compare them to anything we know. And yet, this is only the beginning. The observable universe, the part of the cosmos we can see with our most powerful telescopes, extends about 46 billion light-years in every direction. That makes the diameter of the visible universe nearly 93 billion light-years across. And within this sphere, astronomers estimate there are as many as 2 trillion galaxies. Each galaxy contains billions or trillions of stars, each star with the potential for planets, and each planet with the possibility of life. So when we talk about the scale of space, we're not just talking about size, we're talking about time, history, and the very limits of human understanding. From the tiny blue planet we call home, to the edges of the observable universe, we are surrounded by a vastness so great that it humbles us, and yet inspires us to keep exploring. Asterisk galaxy collisions and evolution asterisk galaxies may look like calm, graceful pinwheels floating in space, but the truth is, they live dynamic and sometimes violent lives. Over billions of years, galaxies grow, change, and even collide with one another in cosmic dances that reshape the universe. One of the most dramatic events in galactic life is a galaxy collision. Now, when we hear that word, we might picture stars smashing together in fiery explosions. But remember, galaxies are mostly empty space. Even when two giant galaxies collide, the stars inside them usually pass by without ever touching. What really happens is that their gravity pulls and twists them, stretching their arms, warping their shapes, and triggering massive waves of star formation. Sometimes, two spiral galaxies merge to form an elliptical galaxy, smoother, rounder, and filled with older stars. Other times, the collision triggers bursts of activity, creating what astronomers call a starburst galaxy, where thousands of new stars are born in a short span of cosmic time. And this isn't just theory, we can actually see it happening. The antennae galaxies, about 45 million light-years away, are a spectacular example of two galaxies their arms are being stretched like ribbons, glowing with the light of newborn stars. These interactions show us that galaxies are not static objects, they are constantly evolving. Even our own Milky Way is not safe from this fate. In about 4 billion years, we will collide with the Andromeda Galaxy. The two giants will dance around each other, slowly merging into a single massive galaxy, sometimes nicknamed Milkamata, from Earth. If humanity still exists, the night sky will transform into a breathtaking display of colliding star fields and glowing gas clouds. So, galaxy collisions are not rare accidents. They are an essential part of how galaxies grow and change over time. In fact, the Milky Way itself was built partly by devouring smaller galaxies in the past. These cosmic encounters remind us that even on the largest scales, the universe is alive, with motion, change, and transformation. Dark matter and dark energy as we've explored galaxies and the vast scale of space. You might think we understand most of what the universe is made of, but here's the shocking truth. Everything we see, every star, every planet, every galaxy, all the glowing gas and dust, makes up less than 5% of the cosmos. The rest is hidden from view, made of things we can't see directly: dark matter and dark energy. Let's start with dark matter. When astronomers measured how fast galaxies spin, they found something strange. Galaxies rotate so quickly that the stars at the edges should be flying off into space. And yet, they don't. Something invisible must be holding them together, providing the extra gravity they need. That invisible substance is what we call dark matter. It doesn't give off light or energy, so we can't see it, but we know it's there because of its powerful gravitational pull. In fact, dark matter makes up about 85% of the total mass of the universe. Without it, galaxies as we know them couldn't even exist. Now let's move to something even more mysterious: dark energy. In the late 1990s, astronomers discovered that the expansion of the universe is speeding up, not slowing down as expected. Something unknown is pushing galaxies apart, stretching space itself faster and faster. That repulsive force is called dark energy. It accounts for almost 70% of the universe's total energy. And yet, we still don't know what it truly is. It might be a property of space itself, or something even stranger. So when you look at a galaxy, remember, the brilliant stars you see are just the tip of the iceberg. Most of what holds that galaxy together is invisible dark matter, and most of what drives galaxies apart across the universe is the mysterious dark energy. Together, these hidden forces shape the past, present, and future of the cosmos, even though they remain among the greatest scientific mysteries of our time. Telescopes and discoveries, for most of human history. The Milky Way was just a band of light in the sky, and galaxies beyond our own were completely unknown. But thanks to telescopes, our vision of the cosmos has expanded farther than anyone could have imagined. The first breakthrough came in the 1920s, when astronomer Edwin Hubble used the 100-inch telescope at Mount Wilson Observatory to study a faint smudge of light called the Andromeda Nebula. To everyone's surprise, he discovered it wasn't a nebula at all. It was an entire galaxy, far beyond the Milky Way. That discovery forever changed our understanding of the universe, proving that our galaxy is just one among billions. Since then, telescopes have continued to push the boundaries of discovery. The Hubble Space Telescope, launched in 1990, has captured breathtaking images of distant galaxies, nebulae, and the farthest reaches of the cosmos. One of its most famous achievements is the Hubble Deep Field, a long exposure that revealed thousands of galaxies packed into what seemed like an empty patch of sky. It showed us that the universe is overflowing with galaxies everywhere we look. And now, the James Webb Space Telescope is taking us even further back in time to see galaxies as they appeared just a few 100 million years after the Big Bang. By capturing the faint infrared light of these ancient objects, Webb is helping scientists unlock the story of how the first galaxies formed and evolved, from Earth-based observatories to space telescopes. Every advance in technology gives us a clearer window into the universe, reminding us that the story of galaxies is also the story of human curiosity and discovery. Conclusion. As we come to the end of our journey through galaxies and the unimaginable scale of space, take a moment to reflect on what we've discovered, from our home in the Milky Way to our massive neighbor, Andromeda, to the local group, the Virgo supercluster, and the vast cosmic web of trillions of galaxies. We've seen that the universe is far larger, older, and more mysterious than anything we encounter in daily life. We've learned that galaxies are not just collections of stars, but living, evolving structures shaped by gravity, collisions, dark matter, and dark energy. We've seen how telescopes like Hubble and James Webb allow us to look back in time, witnessing galaxies as they formed billions of years ago. And we've realized that even though the cosmos is immense, we are part of it. The atoms in our bodies were forged in ancient stars, which means, in a very real way, we are children of the galaxies themselves. When you look up at the night sky and see the faint shimmer of the Milky Way, remember that you are standing on a tiny planet orbiting a modest star in one spiral arm of one galaxy, but also that you are connected to the grandest structures in the universe. We are small, but our curiosity, our imagination, and our quest to understand the cosmos make us part of something truly infinite. This is the wonder of galaxies and the endless scale of space.